Hello everyone and welcome back to another screencast, and this one is on graphs, straight line graphs and parallel lines. If you've watched all the other straight line graphs videos, screencasts, then you'll probably find this ridiculously easy. Hopefully you will anyway. What is a straight line graph? Well, we've done this before. Straight line graphs, better known as linear graphs. The equation we normally use is y equals mx plus c, and we've got to remember that the m stands for gradient and the c stands for intercept, y-intercept. Okay, hopefully you already know that. Here goes an example of a straight line on a graph. This particular one, the equation would be, if I was to write it here, hopefully you could write it here, y equals, it's funny y equals, and it's 2x, and it's going through 1, so it'd be y equals 2x plus 1. But on this one, we're looking at a line running parallel to that. And we are going to try and match up equations with lines and try and get them so that they're parallel. It is very, very simple if we just stick with it for a little bit longer. So I've left up here this up here just to remind you about the gradient value and the y-interceptor. And we're going to look at two lines. Now, I'm going to teach you here that the first line is red, and that is this one here. Okay, we can see that is it's got a gradient value of 2, so you go out 1 up 2, and it's cutting through the y-axis at +1. The next line, if I can bring it up, here we go. This one is again got a gradient value of 2, so you go out 1 up 2, and it's got a y-intercept value of -2. And we can see here that they're both parallel. So what I would like you to do is just take a little quick look at this and think about what makes them parallel. What important part of each of those equations makes them parallel? And very, very simply, it is the gradient value. So as long as the gradient value is the same, then they'll run parallel. Okay, the y-intercept value could be ranging from lots and lots of things. And they do try and trick you sometimes, and we'll go through those misconceptions. But it is as easy as that. Look for the gradient value to be the same. So let's have a little go. Let's have you have a go. I want you to think about which of these will match. So which of the bottom two will match the top one? Okay, so what two lines will run parallel to each other? Give it a go. Possibly even draw out a graph. So I've got a graph here, graph paper here. You could do the same. And just think about which one should be parallel. And this is one of those misconceptions about how they try and trick you. But anyway, let's go through the first one. Let's put the first one on our graph. Now I want you to hedge your bets. Which one is it? Is it 2 or is it 3? All right, so here we go. Number 2, that's running that way. Okay, and this is what they can do sometimes. So you can see here that we've got x here and we've got x here, but it's a -x. So that is a negative gradient. So the matching one was actually the yellow, because we still have our positive gradient and we just have a different y-interceptor value there. Right, let's go for another one. I'm sure now you're well away with it. Again, this is how they make them a little bit more difficult for you. Here's my graph. Maybe you want to draw them all out and see which ones are, but then think about which ones run parallel to each other. Which ones run parallel for each other? Let's do the first one. So if you haven't done so already, pause the video now and do them, but that's the first one there. Where would the second one go and where would the third one go? Pause the video, do them, and come back and see if you've got it correct. Okay, so the second one runs there. So that's the parallel one. So we can see here, there is, and this is no gradient value, but there is a y-interceptor value. Okay, so no gradient value. So there's no x value. Yeah. So that means that they're going to be flat lines and they're just cutting through the y-interceptors at 1 and -3. This one, hopefully you know this because you've done the screencast on this, that runs straight down that line. Okay, so that is not going to be the right one. All right, so now, and there's going to be lots and lots of different answers for these, but what I'd like you to do is I'd like you to write in those boxes another equation that is going to run parallel to the lines shown on the graphs there. So we have on the graph, we have y equals 3x plus 2 on one, and on the other one we have y equals 2 minus 2x. So all you need to do is you need to write another equation that will run parallel to that. Pause the video, come back and see if you've got it correct. Alright, so we should have done that by now. Let's look at the one that I did. What I wrote down was 3x minus 2. And that is running like that. And the key is, as long as I have 3x, then that would be correct. So I could have actually written a multitude of different ones. I could have written 3x plus 1, 3x, plus 1, 3x plus 3, 3x plus 4, 3x plus 5, 3x minus 1, minus 2, minus 3, minus 4, minus 5. I could have actually just written 3x on its own because that would go straight through the origin of 0, 0. On this one, I needed to match up my x values, and my x value was minus 2x. So on this occasion, I wrote y equals 4 minus 2x, and that is like that. As long as you had minus 2x, you were going to be fine. You could have actually just written y equals minus 2x. That would have gone through, again, the origin, but any other number would have been fine. So it is time for the quiz. Write down another equation that will be parallel to the line shown here. All right? Come back and see if you have got it correct. So we should have had time for that now. Here we go. I've written 2 examples there. So we've got our first example, 3x plus 5. The next one was 3x minus 4. And the last one is, and as I said before, y equals 3x. But you could have had anything else as long as it had 3x in it. Happy days. As I promised, it was going to be a nice easy one for you guys to do today. Hopefully you've had a great day. Don't forget to do that revision card and do really well on that. And of course, as always, it's been an absolute privilege to help you with your maths today.